Namaste, dear students. Welcome to Deeksha online bridge course. Subject is physics, and today's topic of discussion is differentiation. It is one of the very important topics in mathematics. To understand some of the physical quantities and solve some numericals, we need the background of differentiation. In today's class, I am making an attempt to introduce you to the concept of differentiation and teach you two formulas related to differentiation. To understand this, let us know the meaning of a function and a variable. We are familiar with some of these equations that we have studied in mathematics. In these equations, you observe that the term y in the equation depends on x. Hence, we say y is a function of x. Here, x is called as independent variable, y is called as a dependent variable. As x changes, the value of y changes. How does it change? In this particular equation, the value of y changes with x according to this relation. Here, y is a function of x. If you put x equal to 1, you get the value of y. You put x equal to 2, you get the value of y as per this equation. Similarly, here y varies with x according to this relation. We say y is a function of x. Y equal to 12x square cos x. If you substitute the value of x, you will be getting the value of y. Y depends on x, so we call y is a function of x. It is not necessary that you always write it as f of x. Some cases you also write it as g of x also. That also represents the function of x. Here y is equal to log of 1 by x. As you keep substituting value of x, you get the value of y. Here x is called as independent variable because its value changes by itself. Y is called as dependent variable because the value of y depends on the value of x. Let's say, for example, your bus fare. The bus fare depends on various parameters like the cost of the fuel, the distance that you travel, and other expenses the Department of Transport will incur. The fuel cost can be treated as X. As the fuel cost increases, the bus fare also will increase. This bus fare can be treated as Y. Suppose the fuel price increases by 2 rupees per liter. The bus fare might not increase by 2 rupees. There is a function, there is a relation may be defined as one of these. In the equations that we discussed in the previous slide, there are certain terms in the equation called as independent variables. Their value does not change will not change with other parameters, they change by themselves. Such quantities are called as independent variables. Some terms in the equation change with the change in the value of other terms. They are called as dependent variables. In the above equation, y is called as dependent variable, independent variable was x. Suppose I write y is equal to a sine theta. As you are assigning the value of theta, theta is called as independent variable, whereas y is called as dependent variable. Same way, in equations like, uh, let's say, velocity equal to distance traveled by time taken. Time and distance change by themselves. Velocity depends on both of them. D and T are called as independent variables. V is called as the dependent variable. Now, how do I get to know one of them is dependent, one of them is independent? You will get to know in the equation, and based on the physical quantity that we are discussing, you will get to know about that. Constants. So in the previous equations, you saw there is a 12 there is a 5, there is a 3, there is a 2. These are all called as constants. Their value doesn't change. These constants, the value remains a constant and will be provided in the particular problem. In physics, similar type of equations, like for example, velocity depends on time. Hence, we call velocity is a function of time. How is velocity depending on time? According to this equation. Here you observe, when I drop a body down at the initial stage, u equal to 0. This becomes a constant. During the journey, acceleration is a constant. This is a constant. So V is depending on T. T is the independent variable. V depends on the value of T. Current is a function of time. Current is equal to charge by time. With the time, the value of current may change because the quantity of charge flowing will increase or decrease. Potential energy is a function of height. As the height changes, potential energy changes according to this equation. Here, mass of the body and the acceleration due to gravity are constants. Suppose you have this lens or a mirror and you keep an object somewhere here at a distance of u meters. The image is formed somewhere here at a distance of v meters. For this length, the focal length remains a constant. Then the image distance changes with the object distance. So I can write image distance v is a function of object distance u. According to this equation, 1 by v is equal to 1 by f minus 1 by u. I hope you got a clarity on the variable which varies due to the variation of other term and a variable which can change by itself. We spoke about the constant. In the mathematical equation, the constant will be a mere number, whereas in physics, the constant is a value in the equation whose the value will remain a constant. It is constant only in a given system of measurement. So, say for example, universal gravitational constant. Though the value is this much, if I change the system of measurement, the value can change. And this constant may have a unit, may not have a unit. Say for example, refractive index of water. It is defined as velocity of light in air divided by velocity of light in water. Meter per second will cancel. No unit for refractive index. Universal gas constant. This is the numerical value. This is the unit. This value will remain a constant. Even in physical constant, you can have a number like 2, half, etc. They don't have the unit. Now let us look into some mathematical functions. Area depends on radius. So I can say area is a function of radius. How is area depending on radius? According to the relation pi r square. Similarly, area of the square depends on each side. That is why area is called as the function of length of each side. How does it depend? As a square. In the equation of a straight line, y equal to mx plus b, y depends on x, so we call y is a function of x. In this quadratic equation, y depends on x according to this relation. X is the independent variable, y is the dependent variable. So y is called as function of x. Don't worry about a, b and c, they will be given in the problem. Now as I assign the value of r, I get the value of a. When r is equal to 2, I call it as function at r is equal to 2, function at s equal to 2, function at x equal to 2, function at x equal to 2. In the equation, wherever x is there or the independent variable is there, you need to substitute that value. So here I get pi 4 square, here I get 4, here I get 5 to 10, 10 plus 7, 17. Here 4 plus 4, 8, 1, 9. Y is 9 when x is equal to 2 in this equation. Y is 17 when x is equal to 2. A is 4 when length of each side is 2. Area of the circle is pi into 4 when radius is equal to 2. Now I want to take you much more closer to differentiation. With this background, let us look into the last equation. Velocity equal to distance traveled by time taken. How do I measure that? Suppose I start from O, reach the point A. I travel x meter in a time equal to t seconds. If x is equal to 20 meters in a time is equal to 5 seconds, then your velocity will be 20 by 5, that is equal to 4 meter per second. I can find velocity like this. Now I don't have patience to wait for 5 seconds. I want to find it at a shorter time interval. Suppose I want to find the velocity at the end of 3 seconds. Now the distance covered is equal to 12, let's say 15 meters. Now the velocity is equal to 15 by 3, that is equal to 5 meter per second. I want to find it in a even more shorter interval. Then let's say x2 is equal to 9 and time taken is equal to 1.5. Then what happens? Your velocity will be 9 by 1.5. This will be equal to 6 meter per second. You see, for the same journey, for the same body, at different intervals, I am getting different velocity. Hence, in physics, as you go to the higher classes, we try to find these physical quantities in very, very small intervals. How? Let me consider the body covers x1 meter in t1 time and it covers x2 meters in a time equal to t2. Then if you observe, there is a small difference in the distance covered. This small, it should be relatively very, very small. Then you call it as delta x. This is a Greek alphabet written as a triangle called as delta. This is actually given by x2 minus x1. Mind you, you may also have to find x1 minus x2. Some cases your x2 may be this much only. X2 may be lesser than x1. This will be your delta x. Even in that case, because it is a difference, delta x can be treated to be positive. It is called as change in the value of x. Same way, there is a difference in the time interval, very short difference, t2 minus t1. So I want you all to understand delta x is a small change in the length. It can either be the increase in the length or decrease in the length. And when in a very small interval of time, delta t. After this, after your 10th standard, whenever you are going to speak about physical quantities, you will come across these small changes always. So here I repeat once again, delta x represents the small change in the length x. It is typically x2 minus x1 or x1 minus x2, whichever is larger. And I am trying to find the change in the value of x for a very small time interval. Suppose you want to find the instantaneous velocity. At that instance, time will be equal to 0. So I will not take time equal to 0. I will try to take it as a value as small as possible to 0. It should be very close to 0 but not equal to 0. Our delta t should be very small and a value as close as possible to 0. To recap on this slide, I am trying to define two terms, delta x and delta t. Delta x represents small change in the value of x. Delta t represents the small change in the value of t. That small change in t should be as small as 0 but not equal to 0. Let's say for example, area of a rectangle. Now the present area A1 is equal to length into breadth. I call the breadth to be B1. This is length, this is breadth. For example, let us take a collapsible gate. This is the breadth, this is the length. With the time, I can either close the door or open the door. When I do so, the length of the door doesn't change, but the breadth will change. If I pull it out, the breadth will increase. If I collapse it, the breadth will decrease. So, what happens when I pull this door to the right by a small value? If this is B1, I will pull it to a new length B2 so that this difference is very small. It is called as delta B. Then what happens? So this is your original breadth B1. This is your new breadth B2. So the increase in the breadth delta B is equal to B2 minus B1. Now, is there a change correspondingly in the area? Yes. Earlier area A1 was equal to L into B1. Now, the new area is A2 equal to L into B2. So, what is the change in the area? Delta A is equal to A2 minus A1. This will be L into B2 minus L into B1. If I take L common out, B2 minus B1. What is B2 minus B1? It is nothing but delta B. So the change in the area there is a small change in the area due to a small change in the breadth. I hope you understood the meaning of small changes. I'll give you one more example. Area of the circle, pi r square. R is the radius of the circle. Suppose I increase the radius of the circle to R2. If this is R1, the area is A1. So the new area A2 is equal to pi R2 square. Therefore, the change in the area A2 minus A1 is equal to pi into R2 square minus R1 square. This is represented by delta A pi into delta R square. I hope you understood. For a small change in the radius of the circle, there will be a small change in the area. These small changes is what we discuss in differentiation. Suppose I have a function y. It is depending on x, f of x. In differentiation, we are going to study how does the value of y change when there is a change in the value of x. The study of the change in the value of y with the change in the value of x is studied under differentiation. We use the term if y is equal to f of x, we define something called as dy by dx. Dy represents the change. Instead of delta y, I am writing it as dy. Why I am writing like that? In depth we will study in PU. But for now, dy represents the change in y. Dx represents the change in x. This is called as derivative of y with respect to x, or it is read as differentiation of y with respect to x. This can be also written as f dash of x. The meaning of f dash of x or dy by dx is differentiation of y, differentiation of y with respect to the value of x. That is, how does the value of y change with the change in x? It is either written as dy by dx or written as f dash of x. I repeat once again, differentiation is the study of the change in the dependent variable with the change in the independent variable. When the change in the independent variable is very, very small. That is called as differentiation. Differentiation of y with respect to x. It is written as dy by dx or f dash of x. Now let us see what is this differentiation. Actually, how do I differentiate when the function of x or y is different form? So first function, y is equal to x power n. When y is depending on x, according to this equation, how do I differentiate y with respect to x? When I differentiate y with respect to x, I get f dash of x or dy by dx. When f of x is x power n, on differentiating, you get the answer to be n into x power n minus 1. If y is equal to so much, dy by dx will be equal to so much. When y is equal to x power n, the differentiation of y will be equal to n into x power n minus 1. This is the first standard differentiation formula. You understand and remember this formula. If y is equal to x power n, on differentiating y, d by dx of y, differentiation of y with respect to x, the answer will be n into x power n minus 1. Let me take one example. In the first example, instead of n, I have 5. The function of x, f of x, is equal to x power 5. When I differentiate f dash of x, if I put a dash symbol, that indicates I have differentiated. This will be rewritten as dy by dx. This will be equal to, according to this formula, the answer should be n into x power n minus 1, n value equal to 5. 5 into x power 5 minus 1. So the answer will be 5 into x power 4. If y equal to so much, on differentiating this with respect to x, the answer will be 5 into x power 4. If y equal to so much, dy by dx will be equal to, n value is 16, 16 into x power 16 minus 1, that is 16 x power 15. What if y is a number 7? Now x doesn't change, so y also doesn't change. Dy by dx of a constant is equal to 0. How do I understand this? 7 can be written as 7 into x power 0. Anything power 0 equal to 1. Therefore, I can write y dy by dx equal to 7 into 0 into x power 0 minus 1. 0 into anything will be equal to 0. Dy by dx is 0. So understand, if the value of y is a constant, dy by dx is equal to 0. Two more equations to understand this better. If y equal to x power minus 3, then your dy by dx is equal to minus 3 into x power minus 3 minus 1. Wherever n is there, I have to put n equal to minus 3. This will become minus 3 x power minus 4. What about this equation? I have thought you only for x power n. Here I have 1 by x square. So y can be written here as x power minus 12. Dy by dx is equal to minus 12 x power minus 12 minus 1. This will be minus 12 into x power minus 13. X power minus 13 can be sent to the denominator, minus 12 divided by x power plus 13. Now let us go to the second function. What if y value was, the y value depends on x in two or more terms. Let's say y is equal to y1 plus or minus y2. That is f of x equal to f1 of x plus or minus f2 of x. Like in the equation, y is equal to x cube plus 3x square minus 2. This is your y1, this is your y2, this is your y3. Then how do I do the differentiation? Then your f dash of x, on differentiating f, you get f dash of x. It is given by the differentiation of the first term. Whatever the sign was there, carry forward, differentiation of the second term. y differentiated, differentiate y1, differentiate y2, continue with whatever is the sign between the two. Say if you want to differentiate this, your dy by dx is equal to differentiate x cube, you know x power n formula, put plus sign, differentiate 3x square, put minus sign, differentiate 2. This is how you do the differentiation for a function which is made up of more than one function. Let us take for example y equal to 3x. We have done x, x square, x cube, etc. Here I have 3x. Now how do I do this? Your dy by dx, don't go under the impression that 3 is a constant, the differentiation of that is 0. If only 3 was given, differentiation of 3 is 0. But here it is 3x. So retain 3 like that only, differentiate x. So it will be 1 into x power 1 minus 1. So this is x power 1. 1 minus 1 is 0. Anything power 0 is 1. So it is equal to 3. Same way, if I have to do this, dy by dx is equal to 5 into differentiation of x cube, 3 into x power 3 minus 1, that is 15x square. Please understand this 5, don't take it as a constant until its value of differentiation is 0. Here it is multiplied with x cube, so retain that 5. Now how do I differentiate the third one? Dy by dx is equal to, first differentiate this, 2 into 3x power 3 minus 1 plus 3 times 1 x power 1 minus 1 minus 1 is there, differentiation of 1. 1 can be written as 1 into x power 0, 1 into 0 into x power 0 minus 1. So this will be 3 2s are 6 x square plus 3. This 1 minus 1 will be 0. Anything power 0 is 1. And this term is 0. That's it. Your dy by dx will be equal to so much. We will understand this based on one numerical in physics. The displacement of the car varies with time according to the relation s is equal to 3t square plus 5t minus 2. Find its velocity at the end of 2 seconds. I want you to solve the problem in two steps. Step number 1, the given equation for displacement is 3t square plus 5t minus 2. After choosing this equation, you need to identify which is the dependent variable, which is the independent variable. As t changes, the displacement will change. I can replace s as y, 3x square, 5x minus 2. So the given equation resembles this. Wherever x is there, they have given t. Wherever y is there, they have given s. So instead of writing dy by dx, I will write it as ds divided by dt. X is replaced with t, y is replaced with s. So this will become, now differentiate, instead of x, try to put t there. 3 into 2 t power 2 minus 1 plus 5 into 1 t power 1 minus 1 minus this 2 can be written as 2 into t power 0, or in simple Only a constant is there. Differentiation of the constant is equal to 0. This will be 3 2s are 6, 6t, 1 minus 1 is 0, anything power 0 equal to 1 plus 5. You know that rate of displacement is nothing but velocity v equal to so much. This is the velocity of the body when the time equal to t seconds. They have asked what is the velocity when the time equal to 2 seconds. Now use the second step. If you remember in one of the mathematical tables, I had written f of 2. Wherever x was there, you were supposed to write 2. Now here, wherever t is there, you have to put 2. The velocity at the end of 2 seconds is equal to 6 into 2 plus 5. That is 17 meter per second. So this will be your velocity at the end of 2 seconds. One more example. The charge flowing through the conductor varies with time according to the equation or relation. Q represents charge, T represents time. Find the current in the conductor at the end of 2 seconds. So in a conductor, when the charges are flowing, the flow of charge will give you current. The quantity of charge flowing is not a constant, it is varying with time. So we need to find what is the current. So the given equation is Q is equal to 4t cube minus 5t square plus t minus 7. If I compare this with my y and x, y is varying with time here. So replace instead of y, replace with q, instead of x, replace with t. Then instead of your dy by dx, you'll actually be writing dq by dt, the rate of flow of charge. It is read as differentiation of charge with respect to time. This will be equal to 4 into 3 t power 3 minus 1 minus 5 into 2 t power 2 minus 1 plus 1 into t power 1 minus 1, and for the constant the differentiation is equal to 0. This will be 12t square minus 10t plus 1. This is dq by dt. dq by dt is nothing but rate of flow of charge. It is called as current. This is the current when the time equal to t seconds. What is the current when the time equal to 2 seconds? 12, 2 square minus 10 into 2 plus 1. So I at the end of 2 seconds will be 2 square is 4. 12 into 4 will be 48 minus 20 plus 1. This will be 29 ampere. I hope this gave you a clear idea why we are using the concept of differentiation. We will now go to the third and the last formula for today's discussion. Y is equal to sin x. Y is equal to cos x. If you differentiate sin x, the answer will be equal to cos x. How did you get that? You will get to know in mathematics. But for now, you understand this is a standard formula. Whenever the function y depends on x according to the relation y equal to sin x, then dy by dx will be equal to cos x. If y equal to cos x, then dy by dx will be equal to minus sin x. Understand? Differentiation of sin x gives you cos x. Differentiation of cos x will give you sin x. Let us solve one problem to understand this. Y equal to 5 sin x minus 6 cos x plus 7. Then your dy by dx will be equal to 5 into 5 is a constant, because you are multiplying, you will retain it like that only. Differentiation of sin x is cos x minus 6 times. Differentiation of cos x is minus sin x plus, now only constant is there. For a pure constant, the derivative is equal to 0. This will be 5 cos x minus into minus plus 6 sin x. So if y depends on x like this, for a small change in the value of x, the small change in the value of y is given by this equation. I will give you one more example. If y is equal to, let's say, 12 cos x minus 3 sin x, then how do I find dy by dx? Dy by dx is equal to 12, you will keep it like that only. Differentiation of cos x is minus sin x minus 3 into differentiation of sin x is cos x. This will be minus 12 sin x minus 3 cos x. With this idea, let us see one problem in physics. The displacement of a particle in simple harmonic motion is given by y equal to 5 sin t. Find the velocity and acceleration of the particle when t is equal to pi by 2. So the given equation is y equal to 5 sin t. So for a simple harmonic motion, the wave or the displacement is like this. We studied in graphs, sinusoidal graph. When the time equal to so much, y value is this. When the time equal to so much, y value is this. When time equal to so much, y value is this. So you observe the value of y is changing with time. So here my y is y only, and instead of x, I am having time. When I differentiate this, what do I get? Dy by dx. Instead of dx, I have to write dt. This will be equal to 5 into differentiation of sin is cos t. But dy by dt, displacement by time taken is velocity, v is equal to 5 cos t. On the other hand, how to find acceleration? You have v. With the time, you see the velocity is also changing. Now again differentiate v. You may get confused now. Same problem, instead of telling the displacement of the particle, if I tell velocity of the particle is given by this equation, then your v is equal to 5 cos t. You observe velocity is changing with time. Instead of y, I have v. Instead of x, I have t. Then Instead of dy by dx, I will write dv by dt. This will be equal to 5 into differentiation of cos is minus sine t. This will be equal to minus 5 sine t. But you know, rate of change of velocity is nothing but acceleration. This is the formula for acceleration. This is the formula for velocity. Now that I got the velocity at time t and acceleration at time t, they've asked me what is the velocity when time equal to pi by 2. In both the equation, put t equal to pi by 2. I got velocity to be equal to 5 cos t. So we will be 5 cos, instead of t put pi by 2. Cos pi by 2 is cos 90. 5 into 0, the velocity of the particle will be equal to 0. Same way, the acceleration is equal to minus 5 sine t. Put t equal to pi by 2 minus 5 sine pi by 2. This will be equal to sine 90 is 1 minus 5 into 1. So acceleration is 5 meter per second square. So this is the acceleration at the end of a time equal to pi by 2, and this is the velocity. So these are the three equations that I wanted to discuss with respect to differentiation. A quick recap of the formula for differentiation. If y equal to x power n, then when you differentiate y with respect to x, this will be equal to n into x power n minus 1. Suppose in the given equation, the terms resemble this, but instead of y and x, something else is given. Instead of dy by dx, use those terms. Like for example, in displacement, we have s is equal to half a into t square. Here, instead of xt is there, instead of y, s is there. Instead of dy by dx, I will write ds by dt. The second function is if y is equal to y1 plus y2 plus y3, then you will differentiate this, you will differentiate this, you will differentiate this, and add if there is a positive sign, add if there is a positive sign. Then if y is equal to sin x, dy by dx is equal to cos x. If y is equal to cos x, dy by dx is equal to minus sin x. So with this background, in the tutorial session, we will try to solve some numericals. Now, before I end today's session, I want to give you all a small task. As we are all in the lockdown at home, I want you all to write a diary. Diary about how you are spending your time in the lockdown period. What is that new things that you have learned, you have observed in life during this time? Try to make a diary of that. And if possible, make a small video or make a small voice record or prepare a small write-up. It would be even best if you can write some code, some cartoon, or something creative about what you have learned during this lockdown period. Do that maybe during one of the tutorial session. I will ask some of you to share what you all have experienced, what you have learned. So until the tutorial session, take care of yourself. Bye bye.